Dear students, so today we are going to learn about the introduction of atomic structure. Before going to start about the introduction of atomic structure, I have given in this slide about the syllabus of BSc first sem. Go through the syllabus and read accordingly. Now coming to the introduction, the existence of atoms has been reported since 400 BC by the Indian as well as by Greek philosophers. They were the opinion that atoms are the building blocks of all kinds of matter and cannot be further subdivided into smaller particles. This is further supported by the fact that the word atom has been derived from the Greek word atomio, which means uncuttable or non-divisible. However, later studies established the presence of small particles in an atom which are known as subatomic particles. Coming to the Dalton's theory. The Dalton's theory is the first atomic theory introduced in 1808 by the John Dalton. Assumptions of the Dalton's theory are: elements are made up of extremely small indivisible particles called atoms. Atoms of a given element are all identical in all respects but are different from atoms of the other elements. Atoms are the smallest particles that take part in chemical reactions. Atoms of different elements combine in small whole number ratios to form compounds. Atoms can neither be created nor destroyed. Towards the end of the 19th century, the scientists like J.J. Thomson, Goldstein, Rutherford, Chadwick, Bohr and many more, as a result of their researches, established that atom is not as simple as suggested by Dalton. It is made up of subatomic particles, namely electrons, protons and neutrons. These are called fundamental particles. Now coming to the discovery of electron. In 1830, Michael Faraday showed that chemical changes occur when electricity is passed through an electrolyte. For example, when 96,000 coulombs of electricity is passed through molten sodium chloride, 1 mole of sodium is deposited at the cathode and half mole of chlorine gas is evolved at the anode. However, the real credit for the discovery of electrons goes to J.J. Thomson. The discharge tube consists of the two electrodes connected to negative terminal of the battery called cathode and positive terminal of the battery called anode. A high voltage around 10,000 volts is applied between the electrodes. The current starts flowing through the gas at a very low pressure of the order of 0.01 mm of Hg. The rays coming from the cathode are called cathode rays. Further, it was found that irrespective of the nature of the gas taken in the discharge tube and the material of the electrode, the same kind of particles were emitted. These cathode ray particles are now named as electrons. The properties of cathode rays are: they travel in straight line with high speed, they exert mechanical pressure, they produce heating effect when they strike the thin metals, they are negatively charged particles, they are detected by electric and magnetic field, they can penetrate thin sheets of materials, they cause fluorescence on the glass wall of the discharge tube and on zinc sulfide screen. They ionize the gases through which they pass. The charge to mass ratio, that is E by m, of the electron is constant. Now coming to the discovery of protons. We know that the atom is electrically neutral. The emission of negatively charged electrons from the atoms of the gases in the discharge tube suggests that some positively charged particles must also be present in them. In 1886, the Goldstein modified the discharge tube by using a perforated cathode as shown in the figure. On reducing the pressure, he observed a new type of luminous rays passing through the holes or perforations of the cathode and moving in a direction opposite to the cathode rays. Thus, these rays consisted of positively charged particles moving away from the anode and were named as positive rays or anode rays, or even they are called canal rays. The properties of anode rays are: anode rays travel in straight line, anode rays consist of material particles, they rotate a light paddle wheel placed in their path, anode rays are deflected by electric and magnetic fields, but in the opposite direction as noticed in the cathode rays. This shows that the anode rays consist of positively charged particles. The value of the positive charge on the particle constitute the anode rays depends upon the nature of the gas and in the discharge tube. The value of E by m ratio also depends upon the nature of the gas enclosed in the discharge tube. Now coming to the discovery of the neutrons. So when we come into the discovery of the neutrons, so in the discovery of the neutrons, the scientist, the Chadwick, proposed this idea. So according to him, until 1920, the atom was supposed to consist of only two fundamental particles, electrons and protons. In 1920, Rutherford found that except for the hydrogen atom, the atomic masses of no other atom could be explained by protons and electrons only. For example, the helium atom has 2 protons in the nucleus and 2 electrons in the extranuclear portion. Therefore, the mass of the helium must be twice the mass of electrons, twice the mass of the proton. But its mass was actually found to be 4 times the mass of proton. To solve this problem, Rutherford predicted the presence of some neutral particle in the nucleus of the atom, which has the mass equal to that of proton but has no charge on it. According to him, the nucleus of helium atom has 2 such neutral particles. These neutral particles were discovered by Chadwick in 1932 when he bombarded a thin foil of beryllium metal with fast moving alpha particles. Each particle was found to carry a mass of 1.675 into 10 raised to minus 24 gram, which is nearly the same as that of proton but no charge. The particles were named neutrons. Now, after knowing the discovery of the neutron, proton and electron, later on they proposed the atomic number and mass number. The number of the unit positive charges present in the nucleus of an atom is known as atomic number of the element. It is denoted by Z. Atomic mass number, or simply a mass number, is a sum of number of protons and neutrons present in the nucleus of an atom. To find out the number of neutrons in the atom, mass number minus atomic number gives the number of neutrons. Now coming to the discoveries of the atomic theories. Of course, we have studied the first atomic theory given by the Dalton. Later on, the scientist, the J.J. Thomson, after the discoveries of the electrons and protons, he proposed his model of an atom. J.J. Thomson in 1898 proposed that an atom may be regarded as a sphere of radius of 10 raised to minus 8 centimeter approximately, carrying positive charge due to protons in which negatively charged electrons are embedded. The model of an atom is called plum pudding model or watermelon model. This model of an atom did not have any experimental evidence and hence rejected. Here I have shown the J.J. Thomson's model of an atom. In 1911, Rutherford performed alpha ray scattering experiment to know about the position of the two fundamental particles, electron and protons, in an atom. The alpha particles needed were obtained from the radioactive element radium enclosed in a box of lead. After passing through a slit, these particles in the form of rays were made to strike against a very thin foil of the order of 4 into 10 raised to minus 5 centimeter thick of a heavy metal like gold. These particles got scattered and were then made to fall on a circular screen coated with zinc sulfide. They produced flashes of light on the screen. From the experiment, he observed the following things. First one, most of the alpha particles, around 99%, passed through the gold foil undeflected. Some of these particles were deflected by small angles. And very few alpha particles, one out of about 20,000 particles, suffered a major deflections by more than 90 degrees and even came back in the same direction. From his studies, he concluded that the atom consists of mostly an empty space. In every atom, there is some heavy body at the center, and this center body is extremely small in size. The heavy body at the center of the atom has the positive charge called the nucleus. Size of the nucleus is negligibly small when compared with the size of the atom. Based on the above observations and conclusions, Rutherford put forward his model of an atom in 1911. According to him, he said, an atom consists of the two particles known as nucleus and the extra nucleus. Here I have shown the observations. So here I have shown the Rutherford's model of an atom and his observations. An atom consists of a small positively charged body called the nucleus in the center of the atom. The size of the nucleus is very small as compared to the size of the atom. Electrons are revolving around the nucleus just like planets revolves around the sun. The centrifugal force acting on the electron away from the nucleus balances the Coulombic force of attraction between nucleus and electron. So based on his theory, he proposes the structure of the carbon atom. The carbon atom contains the 6 protons and the 6 neutrons in the nucleus, and the electrons, the 6 electrons, revolves around the nucleus just like planets revolves around the sun. The centrifugal force acting on the electron balances the Coulombic force of attraction. So at that time, the Rutherford got the Nobel Prize for this work. Later, limitations of the Rutherford's atomic model. So, according to electrodynamics, this chapter was developed at that time. Every charged particle during its motion loses energy. Electron is also a charged particle. During its motion should lose energy. This results coming of electron nearer to the nucleus and ultimately fall into the nucleus. Rutherford could not explain this by his theory. And in those days, the origin of line spectrum of hydrogen was the hot cake. The people were unable to explain these spectral lines. Similarly, Rutherford also could not explain the origin of line spectrum of hydrogen. So these two becomes the drawback of the Rutherford's theory. Students, this is about the introduction of the atomic structure up to the drawbacks of Rutherford's theory. And then later on, the one more theory came into the existence by his own student, that is Bohr's model of an atom. To know about the Bohr's model of an atom, you must know some other fundamentals, so that we learn in the next class.